Okay, welcome back and greetings, engineers. And this is going to be a pretty short video. I'm going to talk about Java data type conversion and some of the nuances with using strings in Java. Now, here's the good news, right? The data type conversions that we've learned in C are nearly the same when we're dealing with Java. So it's a matter, and some things that are different are actually easier. And then actually the same thing with strings. There's strings are actually easier to deal with, and there's a lot more powerful functionality that we can leverage in Java to make some of the common operations that we want on strings to be as simple as possible. Now, before we move on, I just want to point out that some things that we have not talked about yet, I've left out for a reason, and this is things like, how about if statements, conditional statements, for loops, while loops, that kind of stuff. Those really basic constructs that we've been using repeatedly in C. How come we haven't looked at those yet? Because aren't those essential and vitally important for building any sort of logic and code? Well, the answer is yes, they're extremely important. The reason I haven't brought them up or shown them yet is because they are identical. They work the same way with the same syntax between C and Java. That is, if I showed them to you, I would basically be showing you the same thing. Okay, you'll see that as you kind of practice and everything, but there's really no difference there for me to kind of point out and say, hey, this is how you do it, because it's the same idea. All right, so your if statements, your for loops, your while loops, right, they're working the same way. Okay, we don't really have to see anything that's really new or different related to those. Okay, now with that being said, let's talk about data type conversions. And this is really similar to what we saw in C. And if I just want to refresh your memory a little bit with this, and that's if we're going through something called data promotion, which is the implicit type conversion. And this is basically when we go for something that has a smaller data range, right? Typically a smaller number of bits that are being used to store the information. And if we're converting something that has a narrower range to something with a greater range, it's a very straightforward thing. Like, so for instance, like if you have a float to a double, right, that's pretty obvious that a float literally just can store with things with less precision than a double. So it's a pretty easy thing to convert. This is often referred as widening, like widening where you're using more bits or greater data range to store things. Okay, and this is implicit because there's really not much risk associated with doing this, right? If you're converting something that has a narrower range to something with a greater range, okay, like for instance, a byte can go anything from minus 128 to positive 127, right? Or 0 to 256, right? It's 255, right? It has a very narrow range for a byte, right? Just 8 bits versus an integer that can store something like 2 billion and something or other, right? So there's not much risk of converting a byte to an integer, and you're not really losing information, okay? So this is implicit data promotion or widening. They're all kind of referring to the same thing. And there's not much really to show here, but it's worth kind of pointing out that there's no typecasting or needed typecasting that's needed like what we've seen in the past, although we do use that in Java as well. And this is a similar idea, right, as in C. It just happens kind of automatically. And here's a bunch of examples of basically we're converting a byte to a short to an int to a long to a float to a double, right? And if we go and then we print them all out on the screen, okay, we're seeing that everything kind of worked in kind of a way that you would expect. Okay, notice there's no format specifiers needed for printing it out, okay? And that we basically, if we have a string here with double quotes plus something else, that'll actually automatically convert that to a string. So a string plus an integer, or a string plus a byte, right? That's going to actually concatenate everything together as a string. It's going to convert that, say in this case like that byte, it's actually going to convert that value to a string and then print out that whole thing. Okay, so 50, right, gets treated as a string when you have it concatenated with this plus operator. Okay. All right, the other way things can go is we can have this explicit data type conversion. This is where we're using typecasting. And this is where we're going from a greater data range down to a narrower one. Okay, and the reason we want to do this explicitly is the same exact reason we saw in C, is at this point you were saying, hey, I might lose some information doing this, right? These are considered risky, and the idea is to have the programming language make sure that if you're doing this, You're being very clear that you're okay with that happening. So that's why the languages are designed that way. Okay, so going from a greater data range down to a shorter one, we want to use typecasting to say, hey, I really want to do this. This is something that's important. Okay, so here is an example, and this we're so similar to C, right? We've got a double here, and I say I could typecast it to an integer, right? And then if I print it out, it actually then converts it to a string, because literally this is treated as a string when it's printed out. Okay, all right. And because we've truncated everything after the decimal point here, it's risky. You want to be very clear that that's what you want, and that's why we have this typecasting. The syntax is basically identical to what we've seen in C. Okay. We could do some things with string conversions. This we do not have an it works a little bit differently in C. So in C, let me show you the C example first. And probably showing something that, because it's a little bit like we haven't necessarily used it. Here I've got a string that stores value 1050, okay? And there actually is this function a2i, and what that does is it actually takes a string and converts it to an integer, okay? This function in C. A little bit hard to interpret that, right? It's not necessarily the most readable thing. You have to be familiar with what that function is. And then I can print it out with the format specifier indicating that it is indeed a type of integer, okay? That's how to do it in C. You might not have seen that before because it relies on this function that you've either used or looked up before or not, right? If you needed to use it for something, which I don't think we necessarily did. And then in Java, I'm sorry, it's actually a lot more readable, right? For one, when we have a string, we're explicitly saying that it's a string, right? And then we have this integer.parseInteger, and what this function does, this parseInteger, is it converts a string to an integer. Okay, so there's different ways. I mean, if I went through all the different ways of converting things in Java and everything, it would be so much and it would just be boring, right? The idea is there's an awful lot of built-in functionality for converting different data types to another, right? Sometimes you're doing it implicitly, it's kind of automatically. Sometimes you're using typecasting, right? And then sometimes you've got some of the weirder data types, like things like strings, and we can see others that we build later on. And you can use other functionality, such as this built-in function, to convert a string to an integer or strings to something else. Okay, so we have similar ones, like if we wanted to do that as a double, string to a double, etc. Okay, now I want to talk a little bit more about strings before we wrap up this video. Okay, some of this is similar to Java, but I mean in Java is similar to C with some nuanced differences. Okay. And once again, Java actually makes this type of stuff tends to be much, much easier. Okay. Now, let's look at below first. We learned that if we wanted to compare two strings in C, right? So I've got these two strings, hello and hi. I'm using the string compare function, and if they're equal, the value is going to be 0. Right? The value is going to be 0, indicates that they're equal. Right? This is not necessarily the most readable thing in the world to read. You know, it's a little bit. You know, the syntax is a little ugly, it's not that readable, but if you know what that string compare is or you look it up, you kind of figure that out, right? So that compares if they're equal, right? In Java, we don't want to use the double equals for strings, same reason as C, okay? We use this function called equal. So if I said string1 dot equals and then put the second string in there, notice string1 is the one I have up here, okay? It allows me, it's built into the language that I say, hey, this is a string, and I could say dot equals and compare it against another string. Okay, this will return a type Boolean. We'll return a type Boolean, true or false. If it's true, it would run this code block. Okay, if it's false, it's going to run this code block. Right? Okay, now, you don't necessarily want to memorize this stuff. You want to be able to look at documentation when appropriate to be able to figure this out. Okay, if we went and pulled up documentation for this, right, we will see that we could look up what methods, right, what functions are available for type string. And actually, even in NetBeans, I could do something in NetBeans where I do something along the lines of the following, right, where I say string such and such, okay, and if I said this string, oops, it's supposed to be a capital S, I do dot, and there's all sorts of stuff in here, right, that I have access to, as well as all the different documentation that I want to see. Okay, so I can look things up. I can look up what does it mean to say I've got, something like the equals, and I can go to that and I can read some information about what does that mean, right? What does it return, right? It says when is it returning true, when is it returning false. It's also got things where it equals ignoring case, right? That means if I have, like, if I'm comparing capital ABC versus lowercase ABC, one of those would be equals is going to return false, but equals ignore case would return true, right? So the thing is, you want to be able to look things up when you need to, right? You want to be able to use documentation to be able to clarify things, right? That's not copying code, right? That actually really in practice doesn't really work well anyway, because you have to understand the code well in order to be able to copy it and use it for some sort of customized reason. Okay, but that's a powerful thing, is that this is called NetBeans is what's referred to as an IDE, right? Interactive Developer Environment. Okay, and that means it's your environment that has all this ability to debug things, to have, like, when you do this dot completion here, to see all the different stuff and documentation that's in here. Okay, so that's why these tools are so helpful to be able to be productive. Okay, the debugger, by the way, in Java, using NetBeans works really the same way as we've previously seen it using C and with NetBeans. Okay, so keep in mind you still have that available, and it's recommended to use that to help you trace and solve certain types of problems. Okay. All right, so that's one. I'm going to show you a small number of just really kind of useful functions that are related to strings, right, that are built in, where we have a string dot something. But keep in mind, it's a small subset of the ones that are available. I'm not going to sit here and tell you all of them, right? That would be exceptionally boring. I want to show you some of the fundamental ones, give you a couple examples of how you can use them, right? And then beyond that, you want to be able to basically be able to reference stuff and be able to look things up when appropriate, okay? So another one is the compare to. This is if you're trying to compare and determine if, like, one string is alphabetically before something else, right? So if we had two strings, Adam and Beth, right, here equals just gives you true or false, right? A Boolean, true or false. They're either equal or they're not. Compare to works much more similar to the C compare function, right, where we're able to just say, well, wait a minute, is one alphabetically before or after the other? Okay, so in this example, because A becomes before B, it's going to run this first code block here, string 1 before string 2. Okay, just to give you a sense of how that works. Less than 0 indicates string 1 is before, alphabetically, before string 2. Okay, pretty basic. We also we can do string dot length, right? This is kind of similar to our string length function, strlen, right? But notice it is syntactically different. We say the name of the string dot and then length, right? That's how we get the size of the string. You do not need to worry about null terminators in Java, okay? You don't have to worry about running out of space for your strings. Notice nowhere in here do I say, hey, this is the maximum length needed for that string, okay? Here, this example, this code example is going to print every single character one at a time that's in the string. I can do this string dot character at, and remember, strings are really like arrays, so if I said at location 0, it gives me H, location 1, E, location 2, L, location 3, L, and location 4, O, right? So doing that allows me to get at the character at function allows me to get at each specific character where it is in the string. Okay, so this example here prints out every single character in the string. Okay. I can also do things like index of, right? Index of is where I could say, okay, I've got the same string hello, and I say I'm looking for the index of where E is found in the string, right? And that's found at location 1. So it gives me where it is. Which character is it? Remember, because we're programmers and engineers, right? Computer scientists and computer engineers, right, like to deal with starting counting at 0, right? Just the way that things work in terms of how we're storing information, right? Like if we have 1 bit, right, it's either a 0 or 1. So we start counting at 0. If we have 2 bits, right, we have 0, 1, 2, and 3, right, we're still starting at 0. That's why we start counting at 0. It's not just to be mean, right? There's underlying reason in terms of how things are stored in computers. That means that's why we are doing that. Okay. Okay, at location E, or E is found at location 1 in the string hello, right? Because we're counting starting at 0. And then if we look for like L, right, what that does is it finds the first time that shows up, which is location 2, and says, hey, that's the location. Does not continue looking for the second occurrence. Okay, so string index of is a way we're just basically searching and saying, hey, where can we find that in the string? Okay, there is a bunch of functions that are associated with strings. We have things like we could look for substrings, little pieces of things, right? We could do all sorts of different operations. I'm not going to show you all of them. It's not really relevant to go through that. Okay, key thing is building up the fundamentals, like I said before, being able to look up documentation when appropriate, being able to apply that knowledge, right, and be able to apply it to solve problems. Okay. Now I'm going to stop here. Okay. At this point we've seen a lot of the nuanced differences between in terms of syntax, right, the grammar of the language between C and Java. What we have not seen yet, right, are some of the powerful features that exist in Java that do not exist in C. Right? One of the reasons we want to go into looking at Java this semester is because we want to introduce something called object-oriented programming that does not exist in the C language, which is exceptionally powerful and extraordinarily popular, right? And we're going to learn some of the fundamentals this semester, and you're going to have them reinforced that later on in subsequent classes, okay? So we're getting some of the basics in terms of just being able to do certain things, able to read in some information from the user, how to print things out to the screen, how to manipulate different data types, right, and so forth. We're now ready, right, to go in the next step, to start looking at what is object-oriented programming, right, and what makes it so powerful and how to use it. Okay, but we're going to save that for a future video. Okay, so stay safe and healthy, everyone, and I will see you in the next video or in lab.